Embedded systems are components of a larger system, that have the capabilities of a computer but with a special functionality. These systems include printers, smart appliances, smart televisions, medical devices, and others. Embedded systems are similar in concept to static systems, which are systems meant to be operational but in an unchanged state. Their goal is to reduce any change that might create risks which would affect the operational conditions and environment. Examples of these systems include wireless or wired network devices such as smartphones, tablets, networked printers, and streaming media players. Cyber-physical systems are a type of static or embedded systems that control functions in the physical world, such as controlling sensor networks and elements in robotics. Devices that cause movement fall under the robotics, while systems that detect conditions fall under the sensors. Examples include air traffic control, robot surgery, and vehicle energy conservation. Internet of Things is a new category of embedded systems, which include devices that communicate over the Internet to perform activities in the real world. Old mainframe systems could be classified as static systems since they perform a specific action. Game consoles and vehicle systems can be added to the list as well. There are several methods used to ensure the security of embedded systems such as network segmentation, security layers, application firewalls, wrappers, and redundancy. The main issue with embedded systems is that they are usually designed with a main focus on achieving their functionality, with little attention given to their security. Embedded systems are of increased importance, since any security breach can lead to damage in the physical world, affecting humans and property. The positive side is that the attack surface on these systems is limited, however it still exists. Network segmentation is a security control that helps isolate an embedded system from other systems that don't belong to its segmented network. This is accomplished with the use of virtual LANs, or by controlling data flow based on IP addresses, network ports, application filters, and access control. Security layers allow groups of devices with higher security classification to be isolated from other groups, where devices of lower security levels can't initiate communications with higher level devices. This is achieved by performing logical and physical isolations. An application firewall is a form of firewalls that is capable of filtering data traffic at the application layer. It controls access and data flow of an application or service, where the data that doesn't match its defined rules gets discarded. It can be implemented at the network or host side. Updating embedded systems is preferred to be done manually, where only tested and authorized changes are made. This also applies to the firmware updates, after the new versions have been properly tested. Wrappers are a feature that helps the embedded system identify if the update comes from a trusted source. They are a method used to combine the actual update with other authentication and integrity features, that allow the system to make a decision. Redundant security controls should be implemented, to ensure that a breach of a one-layered security control doesn't expose the device. This is achieved by using multi-layered security controls, or what is referred to as defense in depth.